James, good morning. It's Vince. I've been promising you a video. This video I'm going to post on my YouTube channel because right now I'm finding a lot of guys are asking the same questions. And I think a lot of this information will help others and making the right choice. You obviously did some homework before you purchase. There are some things I want to point out to you that I would be careful of. And again, I'm not beating down anybody's system, James. Please don't take it that way. I know the system you bought is very nice. The big thing here is I just want to educate because I feel that that's empowering to anybody willing to spend the kind of money that these machines are. He was obviously willing to spend the right amount of money. James has been, looking at doing this. He's got a business model in place already, and you want to make a smart investment. And there's nothing I'm going to gain by having anybody come back to me and say, why'd you sell me that? There's nothing to gain that way. What there is to gain is if I can educate you to make the smartest decision, then at least you see that I'm cutting through the BS, and I want you to get the most bang for your buck, because if you're successful, I'm successful. And that's the way I look at it. We're a team. I'm going to take you from point A to point B with my chassis selections, and you guys will make the choice in the end. But overall, what I want to cover is design of what to look for when you're purchasing a CNC chassis. I'm not going to cover programming. I'm not going to cover any of that. I'm not going to cover cheap chassis. I'm not going to cover wood. I'm not going to cover plastic. These are not toys. If you're looking at playing with toys and Lego type stuff, guys, just turn the channel now. I'm talking to a guy who has a business model, who wants to sell products from his house or from his shop, and this is something that anybody looking to do, if you're looking to drop this kind of money, and what they usually cost, like I said, is $3,000 to $5,000 to start. That's low end. This video is for you if you want to learn about what to look for when you're selecting a chassis. And again, do the research. Don't believe me, you don't have to. I do this full time, but what do I know? Do the research. I'm telling you to do the research. And something else I'm going to state right away, read. And when I say read, don't just sit there and glance over listings. I have an eBay store. That's my actual website. I do the listings. I try to be explicit in them. If you have a question, please ask, but please read. And I can't state that enough. And this is not directed towards you, James, but a lot of people do not read. They just don't take the time, and they're dropping a lot of money. Take the time. Get away from your smartphone. Take the step back that, pretend technology isn't where it is, and read. Read, learn, and watch and listen, and you guys will pick it up pretty quick what to look for, what not to. So without further ado, I want to cover just some things that are standing out to me. First of all, James's machine he picked, it's out of aluminum, which makes sense. It's extremely rigid. That's the proper chassis format as far as substrate build to purchase. It's going to last forever if he takes care of it. It'll definitely stay rigid enough for normal day machining. And, as far as parts resaleability, that's the chassis you'd prefer to have somebody mill on. Now the next thing I would say is what you want to be careful with. There are a couple of potential red flags I'd be careful with. What you're seeing here down here is an aluminum coupler. There, and I'm 99.9% sure it's an aluminum coupler. I don't know because I don't have the table sitting in front of me, but I'm 99.9% sure. The aluminum couplers with the typical slits in them, those are the couplers you want to stay away from. They will generate more backlash than other couplers. Will you eliminate backlash totally? Let's put it this way. I've never seen a machine with zero backlash. You can eliminate it to the point that on your projects or whatever product you're creating, it's acceptable. That's what we're looking for. Most machinists, that's what they're looking for, is what is an acceptable tolerance. So once you find that acceptable tolerance and you know your machine can produce it and produce that tolerance with a repeatability that you're after for producing products, then you make that choice as far as what you're doing. But once you find that, I would say that's the sweet spot. That's what we're looking for. And like I was stating, one of the red flags I see here with these aluminum couplers, bad choice. Aluminum is a soft substrate. It can be used to make proper couplers. That is not the proper coupler. The accordion style couplers will generate more backlash. To get the machine with the most minimal amount of backlash, the couplers I recommend have a single disc a dual disc. Some of them go up to 3 or 4 internal discs, and they're surrounded by a very hard grade rubber. And those actual couplers you will find produce probably close to probably the lowest amount of backlash I've come across. Now, what does that mean to you? Well, of course it means to you be troubleshooting a lot less. I cannot state this enough. If you're buying a CNC chassis or doing this at all, be prepared to start troubleshooting. You will find very soon there are issues that will arise before you drop all your money and you're ready to delve in and you're going to become a machinist overnight. Think before really contemplate what's your mechanical ability. Because these machines, you become the mechanic. Unless you plan on whoever you buy them from constantly going back to them, and 9 out of 10 times they'll answer your first couple questions. They're not going to do what they should do and really go over in detail what it's like to run one of these machines. I'm telling you, I do this full time. They will always have issues. It's just part of the genre of what you're getting involved in. You're buying a robot. Be prepared to be the mechanic and the programmer of that robot. That being said, the backlash is one of those hidden troubleshooting areas that can produce all kinds of wonky results, especially for circles, more detailed cuts. Backlash comes into play. The guy that's milling wood and is more impressed with doing an engraving, he's probably not going to really care too much. The person who wants to produce parts at in a format that's in resale quality, minimal hand refinishing, backlash counts. So if you're going to do it, I say do it right the first time. Save your money if you have to. Buy the proper couplers, and I will cover those couplers that I was talking about again to show you exactly what I'm looking at and why I picked them. But in general, that's one area I would say to look. One of the biggest areas of this machine that really stands out to me is a potential red flag, and actually probably is a red flag overall, is this belt pulley system on the spindle. Now, why I feel that way. Now, in this system, he's using basically it looks more like a Dremel tool. It's a very small chassis, this chassis. But the thing that stands out to me the most is that the belt, it's a belt-driven Z-axis. Not a huge deal, but one thing that needs to be covered, especially as a novice who's either getting a chassis built the first time, or in this case, I believe this chassis came assembled to him. I'm not exactly certain, but this assembly right here you need to be very careful with, because what you're doing, where you have a normal axis where you're putting radial torque on the shaft, this you're also putting a side emphasis of torque on the shaft. So the rotational torque is also being adjusted now, being pulled to the left of the machine, as well as rotational torque, which means now that stress on that shaft is probably 3 to 4 times what it would normally be. Now, when I say that, it usually doesn't mean a lot. What it does mean is you need to pay very close attention to your belt tension, because I just had a customer, and never had this before, but it was very interesting. He told me he snapped a shaft on one of my steppers. Now, I can tell you guys, snapping a shaft is very hard to do. I mean, it's pretty difficult to do in normal circumstances. When you're talking about doing it, and he claimed the table was actually unloaded, which, again, I don't know. He's probably right. It was unloaded. One of the big keys was when he sent me a picture, he had the pulley attached to the broken part of the stepper. So I knew immediately that was most likely, and I immediately told him, I said, it's most likely the mechanical area of the machine, because he had this stepper for 7 months prior to snapping the shaft. So it wasn't like it was done overnight, but over time, you got to remember, you're putting an inordinate amount of stress on that shaft, and we can't see it. It's not something that can be measured. When you adjust these, you can see there's no real scientific way to adjust the tension. You just simply slide the motor until it engages the belt, and you have movement. Now, some guys go crazy, and they think they're bolting the serpentine belt in their Porsche. That's not what we're looking at. You want to engage this belt to where this chassis is smooth and not too much more stress, because again, all this is doing is raising and lowering your Z-axis. So I'd be very careful on how much stress this pulley has on it. And guys, I will tell you right now, these type of machines with pulley systems require more preventative maintenance. You should be testing those screws all the time. for being tight. Every screw on the chassis, for that matter, should always be checked as well. After about a week of use, I would go over the screws again. If you're cutting real heavy material, I would go over the screws probably every 3 days to make sure you're good. Now, how often you do it is totally up to you. It's your machine. What do I know? I'm a guy on the internet. But I'm going to tell you right now, it'll come up and bite you overall if you don't stay up with the preventative maintenance of the machine. They can make you great money, but you've got to understand what you're getting involved with once again, and they require maintenance. Anything with bolts, I would definitely go over and make sure all of your bolts and everything are tight. If you don't have a torque screwdriver, I would recommend buying one, because you really want all the torque on these screws to be balanced for 2 reasons. First of all, you never have to worry about stripping a screw. Second reason is that stress will be equally placed on all parts connected to the frame. Think about your car bolting your tires to your frame. I mean, it's the same principle. You bolt them to the axle, you're supposed to torque them. Most bolts that are under stress will always have torque or require a torque measurement. Think about what I'm saying. It's purely logical. It makes perfect sense, and I used to do it in full-scale equipment. So I'm telling you, your machine is no different. I'm just applying it down size scale. So think about what I'm saying. It's purely logical, and it makes a lot of sense, and it'll save you a lot of headache. Keep a log. Generate a log, write it down, say, hey, I did it this day. I've already manufactured. Keep track of how many parts you're doing. You guys are literally becoming a facility. The more professional you are, and I know it sounds crazy, the more professional you are with this, you will find you can track down a lot. You'll teach yourself a lot just by keeping records. The big thing there is don't be afraid to write things down. Don't be afraid to try things with, okay, I did a PM today. I'm going to do a PM 4 days from now and see if anything has changed. If nothing has changed, you're fine. You're good. If you're noticing things are changing, of course, you're going to shorten the duration down between PM intervals. So something to think about, something to really, go over in your mind, and you'll figure it out from there. But as I stated, these type of assemblies, be careful with a belt-driven system. I would say just be very, very cautious with tension, and be very cautious with screw tightening, especially on the tension on the belt. Check the tension on the belt all the time. I would check it probably after 5 to 6 runs, and make sure your belt is fine. Make sure your belt has no cracks. They are under stress. They do wear just like a car belt on a serpentine. So please think about what I'm saying. Again, purely logical. The next thing I'm going to go over, and I'm just going to move down here, is I'm going to go over the website that James sent me. And I want to cover some things here. And again, this is just my opinion, and again, I do this full time. This is something you're learning from somebody that I'm just telling you can do your homework on. I hope you do. Check everything I'm saying. I have nothing to make up, or there's nothing for me to gain here. Like I said, I'm just being honest in what I'm saying. The cutting area on this chassis is 310 by 310 by 90. Okay, so we know it's a smaller chassis. There's nothing wrong with it. It's actually one of the nicer, smaller chassis I've seen. It does have the H-frame for the gantry, so we know that's going to be sturdy as hell. One of the big things here that I've noticed with this system, and I'm going to scroll down, okay, again, you've got your Dremel tool type spindle. That's what they're utilizing. Let me see if I can find it. Okay, once again, we're back at the controller design. And James, I have to say, he did the smartest thing by asking before buying the controller. I'm glad he did that. This is where we start running into some questions. And here's my questions. First of all, they got the gimmick for you. Here's the gimmick. Oh, it tells you your voltage. Well, that's great. Do you need to know your voltage? You certainly don't need to know your voltage. Power supplies they'll fluctuate, but certainly not by that degree. That's a gimmick. Don't pay extra for that crap. I'm just telling you straight up. Next thing. I want you to really pay attention to this, and this is something that, again, I can't tell because I'm on first of all, they don't let you zoom in. They do a lot of pointing of what they're doing. You could tell this is a very confined space. There's a lot. It looks like there's aluminum substrate on the inside. You do have your electronics, and one of the big things you'll see here, and I can tell you right away, these are Chinese drivers, guys. Okay, not a good idea. Okay. He's obviously pointing out he's using an 8-wire harness. He's using shielded cable. You know, it looks relatively organized. And I'm going to show you why it's not a good idea. Everything here looks built pretty good. I mean, it looks like he wired it properly, whoever this person is, whoever this company is. Everything looks relatively decent. The thing I would be careful with, again, is the size of this unit. I could tell you right now this is a very, very small design. He does state that he has air holes in the front of this chassis, front air vents. Okay? I'm not seeing a fan. Now, maybe that's me. I'm looking to see, because I looked at this pretty closely, and I did not see if there was anything with a fan. Okay? It's odd. I'm not understanding what that's about. I guess he's thinking that air will just force itself through the case. Again, he's using Chinese drivers, enough said. Okay? The next thing I want to point out as we come down here, he's going into this, you know, here you go again. Motor cables and conduit. He's using plastic nylon coating around the cables. Okay. I mean, I don't know if it's actual conduit. I would say it's just sheeting over the cables. I'm just being nitpicky, but you can see where he's going with that. He does have X-axis limit home switch. Guys, I say this to all my customers. You do not need limit switches. Limit switches are a gimmick. You need home switches if you want to repeatedly machine the same part over again. Your software, motion control software, has soft limits. Learn how to use soft limits. It's safer, it's easier, and it's less wiring for you guys, which means it'll save you money in the long run. So think about what I'm saying. Research it. I'm telling you. Check that out. It'll save you a lot of headache and time. As we go through here, you can see the machine does have the axis set up. Everything looks good there. Again, as we're going through, you can see lead screws. It's going over all that stuff. Here's the couplers I was talking about. These are the other version of the aluminum couplers. These have the rubber jaws inside there. And again, those are definitely not. They're just not good for repeatability. I can't stress that enough. Over time, they wear. You don't know when it's going to wear. It'll bite you. It's something that I would definitely replace. If it was my system, I would replace that right off the bat and be done. And it'll save you a lot of headache overall. As we keep going, I wanted to go over some other things that I noticed. Okay, here we go. Two things. Okay. First of all, if you look at the front, I think this is the front, I'm sorry, the rear of the power input of this box, it says here, I believe it says 36 volt DC out, 11 amps. First of all, he's not even running 48 volts on this system. Okay, whoever this person is who's selling this CNC design place, they're not even running 48 volts, which means, you know, you're not getting optimal speed. You're getting speed, but you can get a lot more. You're still going to get another, 12 volts of speed, which is quite a bit, guys. That's going to it'll make a difference in your rapid movements for a larger table. For a table this size, it really doesn't matter. Once again, I'm just pointing something out, and I'm getting to the point of why I'm pointing all this stuff out. As I come down, again, here is the spindle. This thing is... to me, it's more of a Dremel tool. It's definitely not a pro-grade spindle. We don't know what the runout is on that. Again, it'll work. It's fine if that's what you're going to go with on a table this size. You have no choice. But again, you really want to make sure if whatever you're putting on here, especially if you're doing precision work, guys, your spindle runout means a lot. So think about that. Always look at the runout. Always check and make sure that the tool is true that you're using. This Crest model is a better model, I will say, than what's typically fitted in the U.S. for Dremel tools. So something to think of just looking at that. And again, if you're in the pro-grade market looking for a spindle, believe it or not, the Chinese spindles are not bad. Typically, their runout is pretty true. I use a couple of them myself, and I can tell you they're usually pretty close. I mean, again, they're not a $900 spindle. They're not $2,000 spindle, but it's something you have to think of, price versus what'll work for your job. If the runout is acceptable, then the tool will work. If the runout is not acceptable and the repeatability is missing, of course, change the tool. That's where your budget comes in, and it also comes into what you're trying to machine. So overall, you can see here then the price. This is what I was getting at. This bundle, now James was smart enough to just buy the chassis, I believe. But I hope, and I'm not bad-mouthing you, James, I'm just trying to educate. $1950 for this unit, which it's $2,100. It's not cheap, guys. We're looking at about $2,200 US for this machine. For the size of this machine, you could do better than that. And when I say that, we know that it's got a Chinese driver system. It does come with Vectric's Cut 2D, which I'll tell you guys right now, if you're not a machinist, homework Vectric. Vectric software is the easiest software on the market to use for people who are not traditional machinists. If you want to machine quick, basically Vectric software is the holy grail. I have not found any software myself that is as capable or as easy to use. And when I say that, capable and easy, those words usually don't come combined in the same sentence with a CAD/CAM program. Cut 2D is an amazing piece of software. It's simple. Most guys, I recommend, and I can't stress this enough, download the software before you buy it and play with it. That's how you learn. The software companies know this. A lot of people ask questions but just don't do it. Download it. Get familiar with it. Hell, get familiar with it before you buy your machine. I can't stress that enough. This way, when you get the machine, you'll be that much farther ahead. It makes sense, and it'll save you a lot of time in the long run. But overall, you can see in here, the chassis, again, it's aluminum chassis. That price for a chassis this size is very expensive. I'm not going to lie to you. You can buy a Chinese 3040 chassis, which is about the same size. You could have saved some money there, James. But overall, this chassis, it's an H-frame chassis, which means it is more rigid. How much more rigid, we don't know. But one of the things I will say is that another thing to cover this is for the controller that they're giving you, $2,000 is insane. Cut 2D software runs about $150 if you get the desktop. If you go pro, I think it's like $300. So I can tell you right now, it's a high price system for a Chinese driver unit. That's the one thing I would say to be careful of. If you guys are buying a chassis and you're buying it with all the components, pay attention to the details. Every detail counts, because in the end, it's not one thing that makes this table. It's not just the motors. It's not just the Z-axis. It's not just your travel. It's not just the e-stop location. It's everything. So a table is a bunch of components to make one usable product. When you're shopping, think about that. If you find a weak area, something that doesn't make sense, you can always contact the manufacturer and say, hey, you know what? I don't like those. I really want to change out those couplers. How much to change them out? If their price is ridiculous, you already know you got a red flag. Okay, or if he says they won't do it, you got a red flag. They should be able to work with you on design, because most of these companies are very small, and most of these are small machine shops that are really just reproducing what they're finding online. A lot of these designs are not patented, so use that. When they say open source, it means everybody is playing with it. Think about that when you're buying, and anything that doesn't match up, you can always have them change. Again, box here, we know it's Chinese. This table in this format, I would say anything more than, I would say $1,500 for this type of chassis, this size, with everything, and you probably did good. If you can find it, if you find them used, you could probably pick them up for about $800-900. But the things, again, to be careful with, like I stated, is the belt systems, all of the connecting parts of this unit as far as the couplers. Everything else looks fine. The shafts, he's using ball screws and that. Those are fine. Everything there will be fine. The actual chassis itself is in excellent shape. I would just be careful of those areas. And again, as we come up, the other issue I would say to be very careful with, it looks like, and I don't know where he listed it, but I know I read it, this chassis is actually using 400 ounce steppers. And I can tell you right now, guys, you do not need 400 ounce steppers on this. I don't know where it is. I'd have to look exactly and see. Yeah, I'd have to look and see. But 400 ounce steppers, you just don't need it. He's also running 4.3 amp motors because he's running such heavy steppers. He doesn't need that. That kind of torque on a chassis this size is, you're never going to use that. 300 ounce steppers on this is more than enough. I think you'll be more than happy, James, with 300 ounce steppers. And they'll save you some money. I don't know what they were charging for that. I don't know if they sold them to you with that, but just something to look at. And like I said, yeah, especially right here, this picture right here, you can see the belt drive system. James, just pay attention to that. Like I said, I think you'll be good there. I do see a ground on the chassis, which is nice. You don't usually see that. That's actually well thought out. Again, on a system this size, electrical interference, it might still be present, but that's a real small chassis, so it's not that big a deal. Plus, you're not using a huge spindle, so you know, it's just good practice. I respect that. I think whoever was doing that did it right. I do like the way that they did the grouping on the wires. I think that's nice. Save you a lot of headache there. It does look like they use backlash nuts on the ball screws on the inside of the coupler right over here. But overall, you guys get the gist of what we're going for, you know, as far as what to look out at. Now, James wanted me to tell him about a system to build for him. On a system like this, I will say you can also see this thing has a parallel port. Guys, parallel port is 1985 technology. Okay, when you're buying it, all geckos are parallel port. The weakest part of a G540, I feel, is the parallel port. The drives are bulletproof, but with that port, the equipment you use, the computers you use, and the software you use with them are just crap. I would say that out of everything, that's probably the weakest link. Windows XP is no longer supported. A lot of guys love XP, so be it. I hate it. I like something that's supported. I like to be able to troubleshoot and be done with something quickly. Again, I don't have time to sit back and, you know, oh, well, I want to figure out if it's a computer issue or this or that. You'll find a lot of forum hoppers that's what they do. They'll just go from one forum to another. Oh, I've got this issue. I've got that issue. I've got this issue. I've got that issue. That's not really what you're looking at. If you're looking at simplistic, a USB controller is the way to go. I recommend a UC100 for simplicity. It's made by a pro-grade company, CNC drive. Very, very simple to hook up. It's basically plug and play. You install drivers for it. It's like a piece of hardware. Once that's set up, you're good to go. Some guys like the smooth stepper. The smooth stepper to me is very expensive for what it is, and the UC100 does the same thing. So unless you plan on running over 50 feet of Ethernet, I would say the smooth stepper is not your best friend. So, and like doing a lot of wiring, because it does entail hooking everything up and bolting it in and all that. This is plug and play. It's much easier and a way to go. So what we're looking at and what I'm going to recommend, James, and I'll cover this with you. I'm going to have to look up the shipping cost and whatnot to Australia, but overall I would recommend, and we've talked about this already, guys, for the ones that don't know, I recommend going USB. If you can afford it, go USB. You will have another check mark off the troubleshooting box of having to check, you know, operating system problems, outdated computers. Because guys, here's the thing. If one of these pieces that are connected together to make this system function are not playing well with someone, you're in trouble, because then you've got to figure out and lose time. What's the culprit? Is it my steppers? Is it my e-stop? Is it the spindle? Is it the controller? Think on that. Think from that perspective. You know, if you're really looking at it in the aspect that what you're buying is a bunch of parts to make something, a solid object, you start realizing, God, there's a lot of things that can go wrong. And that's the thing. There are a ton of things that can go wrong. And you really want to make it, if you're doing it from the perspective, I want this simple and easy, do it from the aspect that I'm looking at it from what can go wrong and how can I eliminate that going wrong before it ever does. If you do that and you think of machining like that, you will save yourself tons of time troubleshooting and going over things redundantly. Because I'll tell you right now, if you're a beginner, we all start somewhere. You're going to figure out that what you're biting off and getting involved in when you drop this kind of money, and I don't care the size of the machine, the scalability is the same thing regardless if it's a Haas mill or if it's a micro machine. it's going to be the same as far as troubleshooting. So the difference is whoever owns a professional machine, they usually have a technician that will come in and do it for them. You know, the operator doesn't deal with that. You are the operator mechanic. So think like that. And that's why I say USB, stay modern. Stay with technology that is easy to get support for, easy to delegate. Well, it's this, it's that. It's using the latest operating system, which means it's using the operating system, using the latest drivers. You shouldn't have any issues. It costs a little more, yes, but it makes a lot more sense. I still offer the parallel port because some guys just will buy it in the sense that they feel they want to go Windows XP. I have guys that love XP. I hate it. I mean, and it just is what it is. I don't like software that's not supported. XP is buggy. It's buggy with this equipment, and I don't recommend it. On top of it, if you go with USB, you can also use a laptop, which I use a laptop, guys. I like to use a laptop, and everybody's different. I like portability. If I want to take my laptop home with designing, I can do that. So that's why I said overall, think about what I'm saying. Do the research. That's what I recommend. As far as budget-wise on a system like this, one thing I'll say, James did the right thing. He bought the right substrate of the table. Everything here is firm for what he's designing and creating. You couldn't ask for better. I think it'll definitely work out well. But again, I hope everybody has learned from this. And James, I will send you a quote. I will give you, like I said, we'll do a 300-ounce motor package. I'll go with the USB format with a UC100. We're going to go with the G540. It'll be plenty for this system. You're also going to be getting the bonus of a 48-volt power supply instead of 36. Now, on a table this size, does it matter? It really doesn't. But if you ever do decide to grow, you'll have more than enough power. And the great thing about that too is you're getting 12.5 amps of power. That system he's giving you is 11. It's a little bit bigger, but really the voltage is where you're going to see it. Once again, on a table this size, your rapids will be so quick. I mean, you're covering that area in a matter of seconds. So, I mean, literally, you're not going to see it. But overall, later on, as you do expand and you want to maybe take that table and go to a larger table, you can do that. And that's the big thing. If you're buying a pre-made system, one other thing to cover real quick, you can see all the wiring. He did a beautiful job wiring in the motors as far as with the coupling and everything, so everything's nicely sheathed and protected. The one thing I would say is that, and it sucks with a proprietary system, and this is why I love my solderless, and call it a plug, call it whatever it may be, I'm just calling what I see. And this used to bother me when I was looking, is the fact that all of these are soldered in and connected, which means if you ever decided to sell this chassis, or sell the motors, I should say, because you want to take them off or do whatever, you have to use their controller box to do all that, which means unless you don't want to do that, you'd have to cut all the wires on the motors and resolder and do all that crap. Guys, think about that. Again, more work, more time. It's tedious, and it leads to possibilities of errors. So once again, anything, and I cannot stress this enough, if you learn anything in this video, you're going to learn that what you're buying, all of these parts, and I don't care how big the machine is or how small it is, all of these parts together make a workable robot. If one part is giving you a problem, everything fails. Think about that. Think of like a computer. If your processor or there are parts in a computer that can fail and you'll still be okay. 9 out of 10 times with a CNC, if one part fails, there is no okay. Think about it like that. I've yet to see one part, whether it be minor or major, unless a bolt is loose or something, very, very, very minor. Other than that, and usually the bolt being loose will reflect in a part being created. So think about it like that. Always look at it from a perspective of one part, one of these parts equals about 90% of the production rate of that machine. So always look at it from that perspective. Every part should be dissected as a full-scale machine, because you guys, the ones I'm aiming towards, my demographic that I'm looking at providing equipment for, are guys that are hopefully looking at this as a means of income. So think about that. I cannot stress that enough. Think about, if you're a novice and you're looking at, cable-driven systems. A lot of systems that guys look at too, not just cable-driven systems, are dual-axis, dual-tandem motor axis systems. Very, very nice systems. However, they require more setup. They require more troubleshooting. Keep it simple. If you're a novice and you want to sit there and, you know, really get your machine running, focusing on building parts and creating and learning the software, stay away from tandem drive systems. Tandem drive systems require a lot more servicing. They require more knowledge. And again, if you're okay with that and you're okay with going through all that, then do it. But the setup on a tandem drive system, just from a troubleshooting aspect, 9 out of 10 of my questions I get asked are about tandem drive systems. They see them. There's a couple of my competitors that make beautiful tandem drive systems. I'm not going to lie, they're gorgeous. But again, it's only as good as the person running it. Remember that. You can buy the best. You can have a Ferrari if you can't drive it. If you don't have the knowledge behind it, what good is it? That's the whole principle behind that. Think of where you're at. Think of what you're looking to produce, and remember this. And this is the biggest key to everything. If James bought this, and this is fitting his exact purpose for machining right now and getting his product on the market, and it was within his budget, then he did it right. Okay? If he could have bought this same machine for $1,000 less, then he did it wrong. I mean, that's the thing. You're always looking at that. As you become a business, you start looking at overhead and looking at where can I cut the overhead. But by the same token, cutting overhead doesn't mean cutting your nose to spite your face in the sense of production. You don't want to do that. You don't want to lose quality. You don't want to lose time with hand finishing and doing all kinds of other crap. You want to do it right. So think about what I'm saying, and really, really, if you're a novice, I cannot stress this enough, guys. Pay attention to the drive systems and pay attention to how many motors are on one axis. If you're the type of person that feels you're mechanical and you want to play and tinker with dual axis setups, that's fine. You can do that. You know, again, I'm not trying to sway you one way or another. I'm being honest with you. I'm telling you the truth, and you can check this with anybody who's running a dual axis setup. They will tell you once they get it dialed in, it's a beautiful machine. Once they get it dialed in. But by the same token, it's not just once you get it dialed in, it's if something happens, and 9 out of 10 times it will happen. Plan for the worst, hope for the best. That's manufacturing, guys. Plan for the worst, hope for the best, and I don't care what size machine you own, it's fact. I come from a full-scale environment. I'm telling you now, I manufactured everything. I used to work on manufacturing machines from everything from pharmaceuticals to firearms. The last company I worked for, we manufactured firearms. There was very, very limited excuse for anything outside of the tolerances that we would accept because it would be fatal, of course. So think of what you're dealing with and realize, yeah, you're not dealing nothing that critical, most likely. I hope not. But in the sense of troubleshooting, it's the exact same principle. And that's what I want you to really think about. If you're going to spend that kind of money on a chassis that's using dual axis, one of the big questions I always say is see if the company can convert it to a single axis. A 600-ounce stepper that I sell and that are available, I mean, other suppliers are selling these motors in this size. You can go NEMA 34 if you have to. Get a single axis. It's easier. I mean, for a novice, it's going to save you a bunch of time. It's easier to troubleshoot one area of a machine than dual mechanics. It's easier to go through and isolate not just 2 motors, but typically a tandem drive machine always has a lot of belt-driven parts. Those are more maintenance. Think about that. I mean, I cannot stress that enough. You really, really... You really want to go over those in your mind and think of the troubleshooting aspect. And once it all comes to play and you say, okay, I'm formulating a plan now of what happens first, how do I troubleshoot? Even now, before you order your machine, put that plan of action in place. You know, I went through Six Sigma training. I've been through all the manufacturing training. Again, I've worked for Fortune 500 companies. I'm going to tell you, they have a system that they go through, and you guys can initiate that system for yourselves. It doesn't have to be an elaborate system, but it should be something to where you say, okay, I'm going to put together a troubleshooting sheet. If I find a problem, I'm going to start writing things down and try to eliminate each individual problem as it occurs so that it does not happen again and so that I learn something. Because, guys, I'm telling you, there's only so much you're going to learn. The mechanics work or they don't. You know, when you message me, there's no way I can tell you what your machine is doing. No one can, because they're not there with you. You have to figure it out. That's where that troubleshooting knowledge comes in. That's where the research comes in. And again, most of the research you're doing on your own machine, because no one has your specific machine. And even if someone does, it does not mean it's going to work the same. So take a couple moments. Think about what you're looking at. Once you found a machine you like, start jotting down some ideas on putting together a PM sheet on, troubleshooting and when you're going to do your maintenance, what you plan on doing. Once you have all this stuff done, you'll have a much, much clearer picture of when the machine comes in. Okay, I've got this stuff done already. I can go through and I can go down the line if something occurs, which it most likely will, and you'll be set. And you'll find that if you do that a couple times, all of a sudden you start becoming really good, because you're documenting everything. Your mind is working differently. You've now become more like a robot in that you're troubleshooting consistency. And that's what you really want, is that consistency. You want to be able to go in, and it'll come after a couple months, years, whatever it may be, however much time you dictate to it, it'll come to where all of a sudden you'll get to the point where it's like, okay, this machine, it's doing this now, I know where to look. This is, maybe this bolt is loose, maybe this is tight or not tight enough, and, maybe the power supply is doing this, maybe I'm getting a little fluctuation here, a little noise. You'll know what to look for. But as a novice, I'm telling you, keep it simple. Don't make, even if it costs you more money, keep it simple, because you will learn faster, you will produce more sellable parts, which will make up the difference in the long run, and in the end, it's better to ask and be knowledgeable somewhat. I know there is a lot of confusing knowledge online, and again, a lot of it is scientific. I'm trying to keep it really simple. But overall, just remember, you're buying a robot, and a manufacturing robot requires a lot of manufacturing type maintenance, and that's what you're looking at, manufacturing type troubleshooting. So picking a chassis should be a lot more than, oh, this is big enough to fit what I need, and that's unfortunately what you find. So hopefully I've opened up your eyes, James. Once again, I thank you for your wait. I will be publishing this video, so you guys check it out, and hopefully it saves some people some money, and at least lets them hopefully answer some questions, and have them hopefully ask more questions of who they're buying from. I can't stress that enough. Always ask questions, guys. Always ask, what's it made out of? How many screws are used? Ask all that stuff. There's nothing wrong with that. They're not every manufacturer is going to give that information out, readily or answer you right back, but they'll probably get back with you if they want to make the sale. And, don't expect, they're not there to re-engineer a machine with you. Be understanding of their time, be respectful, and I guarantee you'll get the answers you want. And then when you get the answers you want, you make the educated decision, hopefully with this video and every other bit of research you've done, of what to purchase. And that's the big thing. So once again, James, I thank you, and I hope you've learned something from this. And again, this was not a beatdown session. Please don't take it like that. I love your machine. I think it's got a lot of potential. And with a Gecko driver, I will say it'll rock. It'll definitely be a nice system. But hopefully you know now a little more of what to look for in the chassis and what you can do to yours to make it even better than what it is. And on top of that, you have a system to grow with, because the Gecko system, one thing I'll say is it will fit quite large tables. So if he decides to upgrade later on, he can use that chassis again wherever he goes. And even with the 300-ounce motors, he'd be good to go. So, I mean, it is what it is. So hopefully you guys learned something. I'll do some more videos when I get some more time. Other than that, if you have any questions, you can message me through eDealers Direct. That's my store on eBay. And we'll get you taken care of. Take care.